And then I need to share my screen.
Get that first slide up.
One more sec.
Like password to Wi-Fi and everything.
Yep. There's 2 postings. First slide's up. Awesome. So, wow. All right. That wasn't planned. So it won't be that much. A couple minor things. Well, you have slides for this stuff. So Duo is now a location sponsor of Orchestructure. So if anyone came to the last meetup, I believe, that was at Duo in that amazing space on their First Street location, we are going to be the next 3 meetups. So including my talk next month at the end of May. So super exciting. We'll be back here for the workshop, which is still June 8th. We've now got a official page for that as well. And all the speakers are all set up.
You're doing things out of order, right?
So I am doing things out of order. You need to keep moving. Yeah, so this is the workshop page. The site is up, workshop.orchestructure.io. There's also an event that we posted today. As you can see, the schedule is there. The names of the, kind of generic names for the core topics that are going to be talked about, we tried to kind of go from like a 0 to 60 in terms of developers and sysadmins and DevOps kind of engineers and their interaction with workloads going all the way through to Kubernetes from, their laptop, VS Code, containers, orchestration, and then we have some service mesh with which I think Tim Chapter is going to get into as well. So each of those sessions.
Did you know that?
He knows that. So each of those sessions is an hour and a half. They're meant to be more interactive. So the Jeff's leading one as well. They will have repos that you'll be able to work out of. You'll be able to kind of ask questions, get feedback, etc. And by the end of it, you'll at least kind of have a better understanding of what you're doing and maybe have something to kind of show for it that you've done on your laptop or in your cloud environment, etc. So that's the goal for those. We're definitely looking for comments and feedback on that stuff. We want to keep making these better. There's food for it that's free. The entire event is free. So if you are willing to spend a few hours on your Saturday to learn about some cool new stuff, definitely join us. So go ahead. So Chronicle. So Archie Cohen, who has helped us host at Ithaca, and his wife Laura have started a new publication in Ann Arbor. It's called Chronicle.press. And they actually featured me. She's basically interviewing major figures, people doing awesome things in Ann Arbor, mainly in the tech scene. And she did a great chat with me and got an article out kind of perpetuating StockX and Orchestructure and all the stuff that we're trying to do here. So thank you to them. Definitely check out their site. And if you're doing something really awesome and impactful in the region, definitely reach out to Archie. He's sitting right here, and he'll be hanging around. And yeah, it's just really refreshing that I don't live in Ann Arbor anymore, and this is how I tap into what's going on now. Whether it's U of M, whether it's some new startups, whether it's communities like this and meetups. So yeah, thank you to everyone that's kind of helped get that off the ground, and thank you to Archie as well. So what's that? Yeah, there's no H in here. Just the cron there.
You guys get the fight?
Yep. Okay. Never letting you talk again. Cool. Yep. And then, yeah, like I said, so the next talk is going to be mine, May 29th. I'm talking about continuous delivery and how we implement that at StockX using Helm, Kubernetes, Circle CI. And then right after that is a workshop. There will be no meetup at the end of June. And then the next one will be July with, I believe, Brian also kind of mentioning, talking about GitLab, but in a different capacity. So yeah. With that, I'm going to give it to Jeff because he's smarter than me and way more interesting. So Jeff, guys.
That's debatable. Thank you. I'm not sure if you can tell, but this is going to be super casual and interactive. I'm pretty much going to make a few really bad jokes, and then we're going to look at a bunch of GitLab CI files. So if you have any questions, just interrupt me. I am yeah. Exactly. After giving a bit of background, like I said, we're going to dive into a few ArcTS projects and show their CI files. If you have questions about the CI files or questions about the projects, I would be happy to talk about all of them. Hello, hello. I am Jeff. I am an OSS advocate. I love open source, and I'm also a Kubernetes contributor. I've been with ArcTS since 2016. ArcTS is Advanced Research Computing and Technology Services. It's essentially the HPC group for the University of Michigan. Big thing is I tend to focus on just research, not necessarily the HPC side of things. I actually have a day job besides being a Kubernetes contributor and helping with Orchestructure. One of the big things that we have is this concept of on-demand services. So a faculty member might come to me and say that they need a MongoDB database, or they want to host a research application to just search a bunch of documents in Elasticsearch. Or they are developing their own application and they need a Git repo. Point is, there's a lot of flexibility, and there's not like a definition of what exactly I'm doing. I'm doing a lot. On top of that, there is a Jupyter Hub instance that, while it's not live, like it's not being consumed by the public right now, we've had a lot of requests for it, and we've had to figure out the life cycle for both spinning up and managing a single Jupyter Hub instance, as well as if someone has a very specific need for a Jupyter Hub instance and restrictions or a different config, how do we do that and not break our brain and manage like 5 completely different Jupyter Hub instances? So like I said, this is around GitLab. We're using GitLab and ArcTS. We also have a bunch of Postgres instances. Faculty members tend to like Postgres. And by that, I mean I suggest Postgres over everything else. There is begrudgingly some MongoDB instances. We have Elasticsearch both for the HPC side that I don't manage, and then there are several projects that have small Elasticsearch instances. Some faculty members go, no, I actually want MySQL over Postgres. Some people want RStudio, and there's a shiny web app. It takes R code and then turns it into a nice shiny web app that people can interact with. And some people want a Spring app, and there's Jupyter Hub, and now everything's on fire, and we also have Kubernetes. But, well, Mongo is on fire. No, it's always been really just Elasticsearch, and we're putting something on top of Elasticsearch to just do document searching. Like, theoretically, they could be doing the same thing in Mongo because it's all just JSON. That's all they want, but. Anyways,
It's still better than.
it's still better than Mongo, but this is fine. And we're here because of how and why this is fine. All of our config info, runtime secrets, and deployments is in GitLab. It's not just the code. It is literally the definition for every single deployment that I put into Kubernetes. Weaveworks kind of pioneered this phrase or workflow called GitOps. I bet you no one expected a GitOps presentation. They expected GitLab. But somehow Bob and I have been doing a sort of GitOpsy pattern since before that was a term. The whole point is the desired state of the world that you want to exist is checked into Git. And somehow through, you know, whatever, your host or your orchestration platform or your scripts know to take what you've checked into Git and make it all actually work in production. And this actually sounds a lot like Kubernetes because that's exactly what Kubernetes is. It's declarative infrastructure. So just to kind of visualize the idea of GitOps, you have a developer. The developer winds up checking in some code into your source repo. In this case, ours is GitLab. GitLab winds up, I can't actually read it from the screen. GitLab triggers some sort of a CI job. In our case, it's going to be GitLab CI, but it could be if you're in GitHub Travis, or it could be Circle CI, or whatever. Then there is this GitOpsy type script that gets invoked through your CI job. Voodoo magic happens, and then suddenly you're actually just using Kubernetes because this is the same paradigm as Kubernetes, even if you're not using Kubernetes. But the stuff that gets checked into Git gets applied to your infrastructure, even at times spinning up new infrastructure. So we have a number of projects in GitLab right now, but I really only want to look at 4 tonight. There's a very simple one, which is an R-Shiny server. It is a single container that serves up some stuff and has a UI. We're not going to go into anything past that because I don't even know. But they modify the code on their own. It gets automatically deployed. If they need to revert it, they just revert the Git commit. I am never talked to unless, for some reason GitLab is down. There is a Django web app, which is slightly more complex. Now we're getting into, okay, you have a web app and you have a database server and you're hitting, external APIs. So it's, kind of your typical web app that you're used to. There is Jupyter Hub, which is far more complex. In this case, we're managing a single Jupyter Hub instance in the repo, but we can spin up n number of Jupyter Hub instances that all have their own unique subdomain under jupyter.arcts. And it'll just work if you modify, we'll copy 2 files and modify them, and I'll show you the directions. And lastly, we have the concept of ODS, which is on-demand services, where we actually declare new services for ArcTS, spin them up, and then everything just kind of works. So now it's time for the demo. Does anyone have questions first? Like I said, this is going to be super interactive.
You
And
said people complain when GitLab goes down.
yeah, a little bit.
What impact does that have on running service?
None. The GitLab is really just the source of truth. So yeah, GitLab is the source of truth for how the world should be. Presumably, the world is already how it should be unless it's broken. If GitLab and the world break, then we have problems. If one or the other breaks, it's really easy to fix. Kind of like with Kubernetes. I swear I don't work for Kubernetes, but I do. If you pull out your control plane, all of your nodes are still running your workloads. Now, hopefully the nodes themselves don't go down because there might be problems, but like the brain does not need to exist for the arm to flap around. Any other questions?
You are running your own GitLab, or
We are running our own GitLab. So there is a larger University of Michigan GitLab instance, and then there is also ArcTS running their own GitLab. Part of that has to do with config differences. We are looking to consolidate maybe eventually, but that's above my pay grade, and I don't want to talk about it because I know there are 2 people in here that will tackle. I won't look at them, so they don't look at me.
I'll look at them. So is this just running it like the North Campus site? Why not site run? We're in one data center.
Yeah, we're
on our own virtualization.
So, yeah, so this is running in our own private cloud that was donated to us. It is in a single data center in the Mac. That's just how our instance is for this instance of GitLab.
So this is the site.
Yes.
It's not replicated anyplace else. It is research.
All right. So let me kill Slack and then switch displays and probably have to reshare my screen because, yeah, I don't want to have to continue to look like this. Arrangement, mirror. Oh, that's better. Oh, jeez. I did it. All right. So there we go. Escape. I just want to bring this up again. So first, we're going to talk about rshiny. Actually, who here has used GitLab CI or Travis? No one's going to learn anything. So like I said, the rshiny app is very basic, more or less a single page app. There's no dynamic content. It has a bunch of sliders, and I believe it changes some visualizations on a map, but I don't deal with this. This isn't my app. I just host it. What I did do, however, was set up their GitLab CI file. So we're just going to line by line this, and then if there are any questions, you, again, just shout out. And please.
Is this,
Yep.
They're using GitLab CI file. This workflow pipeline. Make sure this is
Yeah. So in their case, so long as they are just modifying their code and they are not trying to like spin up additional websites with additional ingress, this works. I could create a more complex GitLab CI file that would just let them do whatever they want. But at that point, I would just give them access to our Kubernetes instance and give them a namespace.
We do have some users that do that, but they're fairly locked down.
Yeah. All right. So we have 2 stages. We have yes. Cover your butt. So in this very simple CI job, we have a build and we have a deploy. Variables is just, it's defining environment variables. It's just not called environment variables in GitLab CI. We are running a private Docker repo for various reasons. Also for various reasons, the pull URL and the push URL are different because they're running on different ports. Don't ask. Yeah, it's a pull through cache, so things are super snappy. Both the registry group and the registry user are named fisheries because this is a fisheries app. We are specifying the Docker driver to use overlay 2. Besides Bob, who knows why?
Probably bugs in some other driver.
Almost. Bob? Overlay 2FS is a much faster, much more performant, and much more stable file system to use for containers. And we are using Docker. Their application, like running, nothing at all, but it'll cut down build times in half. If you're just using overlay versus overlay 2, literally like a 50% increase in build performance.
They don't care. This is let's make your life easier and going.
Yeah, I mean, it's like I literally just set that environment variable for everything and just forget about it because again, like overlay 2 is so much more performant when you're doing Docker builds, and it's so long as you are running a newer kernel, newer than 4.4, it'll work. If you're not on 4.4, this is bad.
Could you set these somewhere else, like as a default?
Yes, but I'd prefer not to. I like having like literally this repo defines everything for this. If you pull out this repo and put it somewhere else, minimal massaging, and I don't have to remember that this was a global config versus not, because I just copy and paste one of these 3 files and then generate jobs for other people. It is set on the Docker daemon as well.
So we would have to go through and specify overlay 2.
No, you could just leave it as is. Like you could not set this. And then we're setting the Docker host to be localhost. The reason for that is we are doing Docker and Docker builds, and we are just passing through to the host because we run our own stuff. I mean, we know what we're doing. We're not going to shoot ourselves in the foot. All right, so first, the build stage. You can define multiple build stages. You can also have them run in parallel. In this case, we obviously don't want to do a push before the deploy or the build. So we're going to, do the build first and then do the deploy. So another thing that I should mention, all GitLab CI jobs have a different type of executor with different kinds of parameters. We're using the we're using the Kubernetes executor, which is essentially the Docker executor running in Kubernetes, which means we can specify the image that this is going to run in. So we say we want to use Docker dind. That is the image that this entire runner is running. We also specify Docker dind in GitLab CI because that opens up additional functionality in the runner. By default, the runner is really locked down, and you very slowly expose what you need by exposing these services. Also, if you're doing things like running in the GitLab hosted platform, they will have default things like I want Postgres and I want Redis, and these are just services that I need for my build if you're doing like end-to-end testing. And they'll just spin up and be exposed to your build jobs, which is kind of awesome. So services, we want Docker and Docker. And then here's the super ultra basic script. We are logging into our private registry. We are building, first we're doing a -- pull just to pull down all of the images, dependent images. The reason for this is, actually I don't even remember anymore. It's gonna pull them anyways. I think it's to pull latest because they are using our shiny latest. And I am not gonna fight them on that.
You pick your battles, especially with researchers.
Yes. So we're tagging it.
That was in the CS department. Good God, we never dropped something that ran all around. Did you talk about Alice? No. The labs and stuff.
So LSNA uses us. Isn't fisheries part of LSNA? I thought it was. No, they're part of S. At least this one's part of SI because I know the dude that's running this is part of SI.
Anybody can use that. What do you want? So
I mean,
getting access is trivial.
yeah, it's a hodgepodge. I honestly don't pay attention because I just want to move on with my job and get stuff running. And then, you know, people tell me something's on fire and I fix it. So we are doing a build. We're tagging it with the registry URL and the registry group. And the name of this is rshiny. We are tagging it with the commit SHA because unlike them using an rshiny latest image, we actually label our things in a sane fashion. We are also tagging it with latest because even though we tag things in a sane fashion, sometimes if, for example, Kubernetes falls over on its face and everything comes back up and we have to reapply the ODS config, which I'll get to, those things have latest. So if Kubernetes falls over and we have to essentially restore from the ODS repo, it'll pull latest and things will be okay. Then we push both images and then, hey, only do this on the master branch, and we have a tag of Kubernetes just so I can sort through all the jobs and find the Kubernetes jobs easier. Then for our deploy, things get a little bit different and interesting because we are deploying to Kubernetes, and I do not have the nice and elegant Kubernetes integration between GitLab and Kubernetes. So there are reasons for that. So first, we are now using an Ubuntu 18.04 image. We're going to get curl. Then we are going to get. Whoop, I hit the back button accidentally. It should be running as the GitLab user. Lab sidebar. Because I think the GitLab user is the default executor. Where was I? Oh, so we're grabbing kubectl. We are making sure that. And then we are creating what should be a kubectl config area, which is in, you know, /home/gitlab.kube, and then there will be eventually a config file. We store the kube config file, the entire kube config file, within GitLab CI's secrets and variables area. There are reasons for this. ODS is where it actually makes sense why we do it, but that was sort of the paradigm where we started it, and we do it here as well. And then
You can use like any Docker.
yeah, I could use Alpine.
I'm just wondering, like, there's pre-built images with Kubernetes tools installed.
Yep. I believe when I did this, I did not like how they were done. This was when I first set this up. This was, I think, summer of last year. I should revisit this.
It seems like a big and slow image.
It actually it doesn't take that long.
Have any user, like, have any of the image users?
Nope.
It wins.
I mean, like, if they do,
Well, you'll
things are probably going to break unless they know what they're doing. But
see it in the diff note. I was wondering if anybody ever added anything to that.
I've not noticed. And then we're doing a very simple kubectl set image, the deployment, and then we're setting the new image SHA, and then we're done. And it only runs in master branch. Like I said, if all of you that raised your hands have seen a Travis YAML or a GitLab CI YAML, this is not going to be anything new. It's just going to be how we're doing weird things in GitLab CI. This is the simplest of them. So next will be Django. Oh, wait, I wanted to see how long the latest jobs have been. 4 minutes to do the whole thing. I mean,
That only matters when you're using free GitLab service.
so it would only matter if you're using the free GitLab service, which can also take forever to schedule, let alone run, or if like your executor happens to be something like spinning up something in GCP or AWS where cost actually matters, not just time. But in this case, it's like whatever, As long as it gets done. I should actually revisit that though.
Jeff, you mentioned ODS a couple of times.
On-demand services.
Okay.
So that is sort of the bread and butter of what our Kubernetes instance is, which is faculty member wants Mongo. It's going to get spun up in the ODS cluster of Kubernetes cluster. But we market it as on-demand services because faculty like nice names. That is in that private cloud that we mentioned in the Mac. What is next? I believe Portal is next. So Portal is a new project we're working on that is all about giving people a nice, clean, happy, I want storage and HPC resources and I want it now and I don't want to have to file a ticket. I should just be able to go to a website and then receive my resources. So we decided to go with Django for various reasons. We have our own Postgres backend, but we also have to hit external APIs like Isilon, our big storage cluster. We need to hit that API so we can pull back usage data, and eventually we'll be able to do provisioning. Right now, we just want to provide that window. So this is, that's Gitignore. That is not GitLab. Can I shrink this a little bit? Is that awful for people in the back? All right, good. So this is going to be extremely similar to the whatchamacallit, the R Shiny server. The real difference is the architecture of the app. It's not a single container app. It actually has multiple pieces, like I said. But notice we're setting the overlay to and the Docker host. We are also not using our private Docker Docker registry. We're actually pushing this stuff up to Docker Hub. The reason is this stuff is eventually going to be open sourced anyways, and Docker Hub is Docker Hub. It's just easy to use. So similar parameters as before, tagging it as RTS Portal, pushing to RTS Portal. We're not using latest because this honestly can die and not come back right now because it's just proof of concept. And also the definition of this app is not in ODS for reasons. ODS is much more interesting. And then deploy, use Docker and Docker because I'm doing wget in this one. I should use Docker and Docker for deploy image in the other one. I haven't touched that R Shiny deployment in literally a year and a half. Outputting kubectl version, I think I was debugging something, and then we're doing a deployment. I really came here to do this live and have people ask me questions, so that's that. Yes.
Is there like a staging deploy or something, or it's just like we do it live?
So no, that's actually a good question. So for things like Portal, all of our deployment, like all of the code is actually being tested locally. The only time, and at this point between like the 4 developers, we trust each other to not break things when we push it up. The exception is when the IDM team changes something in your OIDC config, and then you can't log into your app anymore, and they didn't tell you, because that happened. But that wasn't, an issue with our code, unless you count the config changing as our code.
So there's not really a test for CI loop that fails sometimes.
Not in these. Eventually. In Jupyter.
But it could be done in the same kind of data.
Absolutely.
Like don't push master.
Yeah.
Or you can set up a separate project.
Oh, okay. So there are certain things in certain containers where the test is actually run during the Docker build.
Oh, okay.
So if the Docker build doesn't work, then it fails. Likewise, well, yeah, we'll just leave it at that. So I mean, the build and then the deploy step, yes, those are dependent. If the build step fails, for some reason AWS East is broken again, so we can't pull dependencies, the build's going to fail. It's through no fault of the code, but it won't push a faulty deployment. So Jupyter Hub. Jupyter Hub is kind of interesting because, like I said, we define a lot of different things in different folders and files to make it all dynamic. So Jupyter Hub has their own Helm chart, but they don't allow much flexibility in it. So we wrote our own Helm chart, which is really, really simple. It lets us define some PVCs for a Jupyter Hub plugin. And we also, in this Jupyter Hub namespace, have things extremely locked down because it is a very shared resource. So we also have limit range and resource quotas because we have security policies on that namespace.
What is resource quotas with this?
So I think for that reason, well, hold on, I'll look because it's going to be here in a second.
As just a general note, where this stuff builds and where things are actually deployed are two different clusters.
Yes. So there is a, just for overview, in ArcTS, Kubernetes-wise, there are 3 clusters. There is a restricted data cluster where we have services that restricted data enclaves rely on certain services. That's over there. We don't even really talk about that because that can't really talk about much of it. It's like it's running like its own instance of GitLab and stuff for those restricted enclaves. Then we have
For specific restricted data files, not embed school.
So we don't necessarily get an entire department coming to us, not Arc, but us, saying, hey, we want to spin up X. We'll get, hey, I got this $1 million grant and I need this compute resource for 2 years. And it's just that grant, even though they may work for the med school.
Yeah, so that's where I'm at. It's like, I work for the med school and have compute requirements. I actually have a GitLab instance that I don't use. I have. So, yeah, no, I have no idea where this is. So.
End users have no direct access to those restricted
It
data.
is
Us hosting services consumed by people that are in our data.
yeah. But the shared cluster, the ODS stuff, Jupyter Hub, that exists in the ODS cluster. And then there is a services cluster where our GitLab and our Jenkins builds, our Docker registry, all of the stuff that we rely on, that's in a completely separate cluster. And we can talk about why you should have separate clusters versus one large cluster all day, but that line is pretty clear. I would disagree. So the entire reason we have them separate is, yeah, there's one shared cluster where you have, you know, people doing stuff in user space, and they might be able to host each other, but that means that our services cluster is separate, so they can't bring our stuff down.
Yeah,
it's actually
that's pretty convenient person who's in charge of the cluster.
Until you have to do things like kubeadm upgrades, and then you find a bunch of bugs in CNI.
Which is a small price to pay once in a while versus a user can ruin all the time.
Yes, I write awesome Git messages. Now, here's the funny thing. It worked. I do not know why it says the commit failed, because the pipeline worked. We have this one issue that we haven't run down where if you do a new Kubernetes, if you spin up a new deployment or you trigger something where your Kubernetes nodes try to pull a new image, it will time out and then it will work. But the problem is it times out longer than the Helm chart for Jupyter Hub needs to run. So the Helm apply fails.
It still works.
But then you can go in and literally just redo this build step. It works. But for some reason, it's not reflecting that here.
There are images that are like any size.
Yes, Jupyter images are fat. And it makes me sad, but that's what we have to deal with. Not their data, but it's like, I want 2 different types of Python with literally every scientific package under the sun. So the image, yeah, I mean, because it's Jupyter, they don't want to have to.
You don't want to have to install it.
I actually back this.
So you guys don't supply, here's a white list of dependencies that we have installed on.
We do. But the problem is, by default, that list is huge. So
there's also a difference between what's run on like the HPC clusters and things like that, and what we run in containers and things like that.
unfortunately, this is kind of bridging the gap.
Yeah, but they get to
No, the Jupyter. So we're getting into weird territory specifically about Jupyter Hub and the way we're setting it up. For how it is right now, with the fact that I can support multiple, say I want jstick.jupyter.arcts instead of the base Jupyter.arcts instance, right? I could define my own image, and then that would just work. We are not going to allow people that want their own Jupyter Hub instance to come to this repo and add a bunch of their dependencies. If they need their own image outside of the one that we provide, they can set their own image. They can build their own image and they can toss it up in Docker Hub. That being said, crap, what was it? Caltech? I think it's Caltech. Caltech is the primary developer for Jupyter Hub. It's kind of weird. They have a lot of staff that are contributing to Jupyter Hub, but they don't exactly own it. They are teaching, it's now like 20 data science classes with 10,000 like concurrent students hitting their Jupyter Hub instances, and they have one image. So I was like, good enough for me, and then based it off their image. Like
the way, like, there's an agent that runs the cluster that pulls the image on those set match from a selector. So wherever the stuff is meant to run, it will essentially pull it.
So yeah, so that way, if they do bring their own image and it's 6 gigs in size, that's fine. It will still pre-pull it, so when someone comes to spin it up, it's already there. Likewise, whenever we rebuild a new notebook image, it triggers a pre-pull across the cluster anyway, so it's super fast.
Another sort of good
All right,
example.
so if I would just import like NumPy, that's it. That's not going to incur any kind of overhead, basically.
None. It's already there. Yep. So the other thing that's different about how we have this set up, user home directories are persistent in this Jupyter Hub instance. So you can pop open a terminal in Jupyter and then conda install something, and it will be there for you.
And, well, they can also catch data.
Yeah. But they only have a gig. But I mean, this isn't actually directed primarily towards researchers. This is actually directed towards classes.
So, but also, does it have access to the Iceland cluster?
No. No. Just because the portal app can talk to the Iceland cluster does not mean anything in the shared cluster can talk to anything outside of its little sandbox.
So what's the back of the story?
Spinning disk in the Yottabyte cluster. So it's probably just like the equivalent of RAID 5. RAID whatever. You could perform. Or
It's the Yottabyte thing. Large images is definitely not unheard of in data science in general. It's actually pretty common to see images of like 15 gigs in size.
it's gross, but it's true.
Yeah, so like OpenAI and the big OpenAI initiative, like when they start doing stuff like the machine learning around like Dota, they actually have to bundle in the full game client, and so that itself is like, I think, well, Jeremy would know. How big is the game client? 12 or something like that.
Fun story about that. For you guys later.
So I mean, while everyone should strive to make Docker images small and things should be, super fast and performant, there are actual reasons why you should have larger images.
There's work being done so that way you can cache those images on a fast performant shared files. That way you're not having to download them to every post.
Yep.
Yeah, well, like IPFS. storing.
You'd still deal with the individual Barlow Docker, the local cache on every host.
Oh yeah, but like
This is so that way you can have all the hosts pointed at a central, like, clustered file system or NFS or something like that, and being able to preload all the layers on that shared file system. You've already invested in making that shared file system incredibly performant. There's no reason to have it copy over to every single host.
And to be clear, this is like stupid scale. This is specifically efforts being made at CERN because terabytes of data and everyone wants it now. Exactly. Yeah. So this is interesting in that we are technically building 2 containers at the same time, pushing 2 containers at the same time, and then we run a deploy. Because we have the Jupyter Hub definition, which is just this like auth endpoint where you log in via a web app, it identifies who you are, and then it will spawn a notebook, and then the notebook image itself. Both of these things are in the same repo because it's just a lot easier for me to maintain, and it also lets other people iterate faster. So we have the build hub step. Note that we define our stages up here, and then we name our stages down here, but we also, or steps, jobs. We name our jobs down here, but we set their stages. So in the previous ones, it seemed a little redundant. Here's why it makes sense. So this job is named build hub as part of the stage build. So when we hit the build stage, this fires off. It's going to be very similar to everything we just saw. It's going to build a notebook, and then it's going to push it.
The stage builds fire in order to
That's what I'm getting at. So we also have build notebook that is part of the build stage. By saying they are both part of the same stage, they fire off concurrently. So notebook and hub get built at the same time as completely separate jobs and completely separate executors within Kubernetes because we're using the Kubernetes runner. And then we just let Kubernetes figure out where the load is and how it should, which node should have it scheduled.
So with enough parallelism.
Yeah.
We have restrictions in place to prevent that from happening.
We do. Then we have the deploy stage. And at the deploy stage, you're going to see something a little bit different. We are actually grabbing Helm. And the reason we're grabbing Helm is because, like I said, we have the Jupyter Hub Helm chart, which we are creating our own kind of chart off of to do some specific layering. And then we are running that. So what happens is, grab Helm, set it up. Again, we are echoing out our kubeconfig. We're telling it to init and set it to client only because we already have Helm installed. We don't want it to try and re-init on our cluster. That would kind of be awful. We are adding the Jupyter Hub Helm chart here just so this locally has it. We're telling it to run the we're telling it to update just because I found wonkiness where it was getting cached, and in real life it's different. And then we are running apply.sh, which is the introduction to the ODS-isms. So instead of having one GitLab CI file where it has a bunch of bash logic, you're going to shell it out to something else. Yes? Yes. So let's show you what that looks like. Super simple. In this case, we are looking for every folder that matches instances, asterisk, and then doing something. And in that, we are going to then source the folder name helm.sh. So if we look at the only instance right now, we look at then helm.sh, and suddenly we have the actual command to run our Helm upgrade using our custom multi-hub chart. In this case, we're saying, hey, spin this up in the Jupyter Hub namespace because we have a whole lot of pod security policies and just controls in place there. We have an NFS client as our backing storage class. So whenever a PVC is created, it spins it off because Yottabyte has an NFS server that we use. This Jupyter Hub instance happens to use Postgres, and we have that set up in the background as well. It's all duoified. This is just a bunch of specific Helm config stuff for this Jupyter Hub instance. However, if I wanted, oh, and there is a config.yaml that I'll open. But the thing about this is if I wanted to create another Jupyter Hub instance under jupyter.arcts, I would follow this here documentation, which essentially, I'm not going to make you read it. Copy the jupyter.arcts folder, rename it, find everything that references that, rename it to the domain name you want, commit. It will spin it up. Oh, see, look. Like I did nothing, and now it shows that it passed. Whatever. But yeah, once you push that up, we have not dynamic. We have wildcard ingress and wildcard SSL, all for star.jupyter.arcts. So if any of those get pushed, it's automatically going to have SSL set up. It's automatically going to have ingress route set, and DNS is already pointing to the ingress IP. It'll just work. No, so Jupyter.arcts is using a different certificate than the wildcard certificate, which we have. And I believe, if we go into the config.yaml, it actually, you have to set the secret name, and that is a Jupyter Hub. That secret is specific to this instance of Jupyter Hub. There is a,
They can't.
no, they can't. I want to,
Why do you feel pressure the Helm's already updated if you then already have your own?
I saw wonkiness locally, and if I see wonkiness locally, I just make it work up there. All the time. Like, I could certainly go, I could certainly go through and clean this up, like I've said. This is like raw. This is, I have done nothing to clean this up. You were seeing all of the like dirty laundry of GitLab and how I use it. That's how we tend to do things, just because it's easier and honestly it's safer. And we've run into certain DR instances, not at Arc, but at our last job, where it's like, thank God we did this, because, oh, our data center flooded.
Said you had Coop config and a secrets manager, the whole string or whatever the document. You have multiple ones of those, I assume.
For each namespace and each project, they are all scoped differently. They're all hidden, so it's like, oh no. The fun story. Do not name this kubeconfig. Otherwise, when you try and run kubectl, it's going to break because it's going to expect it to be a file path to your kubeconfig. I didn't, like, I knew that, but I didn't think about it. All right, so now we shall talk on ODS. ODS is honestly where a lot of things happen because, again, we get a lot of requests, and that's where I tend to put all of them. Projects, come on.
ODS stands for
On-demand services. Gesundheit. So notice that we have a single stage, and it is called deploy. We're not building anything. In this repo, all we are doing is defining pre-built, predefined services that we want to spin up for people. Very similar, we're grabbing kubectl, we're echoing out the kubeconfig, and we're running apply. But the apply script is a little bit different.
The reason why you're running that one is sourcing it.
Dirty secrets. Real, like the Jupyter Hub one is more recent. Like I worked on that 3 days ago, and this one doesn't inherit any like environment variables or anything. Whereas, yeah.
So is that the rule?
There we go.
You have to touch it. You have to fix it. That's the deal.
Yeah. If no one tells me it hasn't broken, it's not broken. Apply it out of stage. So there we go. So in this case, I love my documentation. Assume this is being run in the correct directory. So we assume that this is being run in the correct directory, and it looks for literally any YAML file. And if it finds the YAML file, and the YAML file says no touching, or the YAML file says it's, or if the YAML file isn't a config map, then it just applies it.
I had no part in this.
If it did, yes, I do. Now, if it detects a config map, we have to have a little bit more logic. If the config map exists or doesn't exist, then we apply it. If not, then we replace it. And that's it. But let's see, you know, what this actually means. Let's go into the deployments directory. So in this case, the RShiny app that I discussed earlier, the definition of it in Kubernetes is separate from the code base. So we let the people that are working on the RShiny, you know, server do their own thing and push it, and then their push triggers an image update. But the actual definition for it in Kubernetes resides in ODS.
How do they register?
They have to go through me. Or we have two different groups that have asked for access to Kubernetes, and we just gave them access to their own namespace. We have
Very restricted.
very restricted. We have a thing called Keycloak, and then we tie it into LDAP. So they still have to log in, do all the authentication, and they have to be part of an LDAP group that we maintain. But then they have access to Kubernetes in their own namespace only, and even that namespace has a lot of restrictions on it. And then we are trusting Kubernetes to keep things locked down. It's not so much trusting LDAP as tolerating its existence in its current form.
Because the library can change.
Use RBAC to restrict.
Yeah.
RBAC and this, they're locked down to that namespace.
The name, sorry, so it's RBAC, PSPs, and resource quotas on that namespace.
Sure, resource quotas are.
And one of the things in that Jupyter Hub Helm chart that you might have seen was limit ranges. If you create it, I'm not sure if everyone or anyone knows this. If you create a resource quota and you do not set resource limits on your deployments, they will not be accepted.
Isn't it the namespace level at that point?
Yep. But if you try and submit something, it won't be accepted because it doesn't know what the limit should be.
Correct.
Limit range is just a default.
I actually have read all about this, so I know that piece. But I didn't know the RBAC piece. I have not experimented with restricting that, but that's a thing.
There's other things that I thought about doing that's mostly going on with OPA, Open Policy Agent. So we can basically force like they can only create certain Kubernetes objects. So we don't want them to create service type load balancer because in our cluster, even if they created service type load balancer, they wouldn't actually be able to access it. That's the virtualization platform we're on doesn't have any direct integration with Kubernetes, so that requires us to set a native mapping.
Yeah, I would think you wouldn't want. I mean, I'm shooting off the cuff, but like you wouldn't want someone to build the pods edit configuration that you had said in Helm. Let's say you don't want someone to.
Since they're locked down to their own namespace, and we're going to have fun.
Right. Let us know if you need it redone.
Yeah, they can do whatever they want in their namespace.
And you can go, but you can deploy the vanilla back to them if they mess it up or something.
And some of it's on them. Like some of them, they don't want to use our CI, they don't want to use anything like that. They just want nice access. Okay.
You'll probably be surprised by the answer.
No, but I'm just saying the number of people that would go to ask for it.
Yeah.
I heard about this magic thing that runs.
I've seen those requests. Hey, I want like
OpenShift is a CI platform. No, it's not. But like the thing is, people hear about a hyped term and then they're like,
sure, but that looks like a different kind of request. So.
I have seen people specifically ask for Kubernetes or a container orchestration platform. And then we gave it to them and they said, how do I do this? So
Can I ask one more question with the limits?
ask all of them.
So did you? So I wanted this to be a community exercise of utility.
Actually,
You have to-
while you do this, I'm going to pull up the Jupyter Hub one.
So you have to set some resource limits, and you have to say the namespace has a total of this limit, right?
Yes.
To determine those numbers, what did you use? Did you start out with like a basic? Okay. Okay, I was gonna say because that's the part that always seems wrong to me because I want the performance test and get an actual number and
Yeah.
know what a tipping point is. But that's not the easiest thing to do with millis of.
Within so we generally have some sort of conversation with them and figure out sort of how much total resources they there might be some back and forth like no, that's completely unacceptable. You don't need 256 gigs of RAM to run the web server.
But it's Java.
Turns out to bring molecular dynamics in the back end.
Yeah.
What?
And the other, so like we talk with them about what they might need, but when it comes to like the defaults they can override.
Yeah.
If we give them 256 gigs of RAM, but the default is 16, that doesn't mean everything's going to be 16. They can override it. But if they don't specify it, it won't throw a admission error, which
Like
is
when
the
you
problem.
throw those limits down, have you seen a scenario where they go to play something and it's over? The limit was too low or whatever.
Nope. Again, we do not. Everything is bespoke. Everyone tends to start with a ticket. There is a conversation. If their need is not a simple, I need Postgres and I need 10 gigs of RAM, then we tend to have a meeting, discuss what they actually need, because oftentimes they don't actually need or want this. They actually want the HPC platform, but this is new and shiny. And free.
Standard.
Right is indirect.
So to get to your point, or to get back to this, for Jupyter Hub right now we have 16 cores, and then we have 16 gigs of RAM, and then each notebook spins up with a fifth of a CPU and 256 megs of RAM, and this is being generous. Like Caltech is 0.1 and 128.
So those are both portions of an actual percentage of CPU, is that right? No.
So in this format, this is 0.2 cores.
Yeah, it's funky.
I know. I've done the conversion. It doesn't make sense each time I do it. Then I go read about it some more. And
The kernel metrics provider is awful. It does, like, unless something has changed in the last 4 months.
Yeah, but you guys wouldn't do anything to grab that yourself.
No, well,
There's a Prometheus exporter.
that's all we do. So we're not looking at notebook-specific things. We are looking at pod-specific things in terms of Kubernetes, because the notebooks and Jupyter Hub has a Prometheus endpoint, and it does things like the average Jupyter Hub request was 0.01 seconds, and it's like, that tells me nothing about the notebook usage. That tells me how long a login took, which I guess is good, but that's not most of what people are looking for.
Yeah, it's after 7.
I know.
A couple more minutes and.
Yes. So that R Shiny app, is a very simple deployment because it is a single replica of a single R Shiny app. We define the container here. I don't want to talk about Kubernetes because I do that all the time, but this is just like, if I changed this to 2 and clicked apply, the apply script would notice that there was a difference in the deployment and automatically push it to the cluster. Unlike the other repos that have locked down kube configs, this one actually has far less restricted kube config permissions. And the reason for that is we can also spin up namespaces using ODS and other whimsical things. Any kind of Kubernetes object, as long as you can define it in YAML and put it in here, it'll go. So we also have databases. So like Postgres, quick and simple Postgres one. We set up PVCs. By default, this will spin up a volume using the NFS client, because all of that is defaulted here. We have our own Postgres image, and the reason for that is by default it will spin up, generate a new TLS cert, and only accept TLS auth. And that is like the safe, and I'm not going to deal with you hosting a database that may or may not have sensitive data. Like, that's the safeguard. Spin this up, it'll automatically do it. The only manual step is it spits out the certs to std out, and I have to copy them and then give them to the researcher. Starting to talk faster now. Postgres. I also label every, as of like a year ago, I label everything with the ticket number that I had to deal with, just so it's like. So the interesting thing, however, is Postgres is a TCP service, not an HTTP service. And Nginx Ingress kind of supports TCP ingress. So what you have to do is you, in the ingress Nginx config, specify the name of it, the port, and the protocol, and the target port into the service. But then you have to go and create a config map that Nginx Ingress looks for, and then also map that. Otherwise, the Nginx Ingress will not look at TCP. It's dumb. There are better ingress controllers, but we're not using them. Also in this repo, the logic to tell people, hey, log in, here's the cert you need, that's all in here. And any other weird questions? This was part GitOps, part GitLab CI, part we're doing weird stuff. It's really meant just to provoke questions and have a chat. Not yet.
We had a registry that predated.
Yeah, so this GitLab instance is as of 2016, before the registry was open sourced in GitLab. So we were already running our own. It's Nexus, which is not just Docker images; it's an entire artifact repository. So we're just sticking with that because we have things like Ruby gems for custom builds of things in there. It's a PyPy cache as well, and we also build VMs that our Enclave service uses, and we store those in that artifact. So it's there. We just, if I spun this up like today from scratch, I'd be using that. Managing less is more.
Why don't they do this?
Both at work and personally, no.
For more complex workflows, like strictly CI/CD speaking, GitLab plugin enough. If we actually have to do more complex things, probably use it like plugin.
I'm gonna cut off here so you guys can get out of here quickly. I think you guys are we're gonna be hanging around for another 20 minutes at least. So 20 minutes, half an hour. So you guys.
You have me for 7 minutes, and then cat number 4 demands my
cat
attention.
Number 4. I forgot about cat number 4. Well, Jeff is always available on Slack. Let's give him a round of applause. He answered a lot of questions.
Thank you, thank you.
Like, talk about deep dive. I probably could come in as you one day and do your job just perfectly fine. I don't joke that hard.
Later.
I'm joking. Thank you everybody for coming. There's a lot going on in the next few months, so we'll be communicating as clearly as possible for all the awesome stuff. Jeff will be sharing his slides and any relevant content. More details about the workshop sessions, how to prepare your laptop for them, Minikube and other services, etc., and more on the details of each session and what's going on will be coming to you shortly. Thank you so much for taking